Hello, welcome to another problem session. So today we are going to do a very standard topic of this called thin lens equation. And you probably remember this formula from class or sometime you've seen this before. P is the object distance. This is the object distance and this is the image distance. And this all along the x-axis. This goes with another formula, which you call it magnification of the image, which is height of the image over height of the objects. So this is along the x-axis. This you can say along the axis. So one example will be this. This is the axis. So we convert x-axis, and then there are maybe this. This can be y-axis and things along the y-axis that can be in the magnification. But because of the geometry, you can always relate this to minus q over p. Okay, so for instance, if I have a object here and maybe it forms an image over here. So what does it mean to form image over here? If you take a point here, all rays that come from this point, they all converge. And of course, if you put a screen here, they're going to be bright over here, but they all continue in space, right? So, but they all meet. If this is point A, this will be A prime. Take another point B, do the same thing, point B. So, point B will have corresponding B prime here. And through the center, it's going to go straight through. So this is called chief ray in a way. Is through the center. Any ray that goes through the center, it doesn't deviate, but other rays bend, and such that all the rays that came from B end up going through B prime. All of them, regardless of where they go, they hit here, but they go that way. Hit here, they go that way. No, go through the B prime. Of course, they're not going to hit there. This is just going to go. The one that don't hit the lens, they're not going to bend. So if you take all of them, the x distance, this distance is the p, and this distance is the q. If p was infinity, you can see the q will be equal to f. So if you took a ray that's very far away, and after going through this lens, it's going to go through this point. So this is p equals to infinity ray. This ray will have this distance q will equal on the right side the focal length of this lens. Okay. All right. So this is a little introduction to these two formulas, and you can say over here, if this is the height of the object and this is the height of the image, and q is greater than 0 this way, q is greater than this way, p is greater than 0 that way. So if you have this convention, then you can see that hi will be, I don't need to put a negative sign here, this will be signed properly. Ho will be greater than 0, hi will be less than 0, as this formula will also say. All right, let's do a couple of examples, some numerical examples, just to get a feel for this. Okay, so this is a simple example. An object 10 centimeter tall, placed in front of a converging lens with focal length 25 centimeter. What is the image distance and what is its height? Okay, it's really simple. So we have a p equals to 30 centimeters. So on the left, what the p is greater than 0, so it remains p 0. and we have f, this converging length, so this is going to be plus 25 centimeter, and from there we can just use 1 over q equals 1 over 25 minus 1 over 30, and so we can see have a 70, just multiply these guys together, 750, so you have a 30 minus 25, and so that's going to be 5 over 750. So Q is actually 120 centimeters, a meter and a half, so it's going to be kind of way over here. The Q will be way over here. From this distance, way over there, that's where the Q will be. That's the Q, 120 centimeters. What the height will be, how tall, I'm going to go very small, because you can see this will have to map through the center to the tip here, so it's going to be very small. Let's see, HI is going to be, or very large. I think it's going to be large, not small. Just said exactly opposite. So this is going to have to travel quite a bit to meet the tip over there. So it's going to be large. Let's say it's going to be large. HI equals to, use this, minus Q over P times HO is minus 120 over P was 30 times 10 centimeter. So it's minus 40 centimeters, like a 4 times HO is going to be 4 times H large, and it's going to be quite magnified. Okay. And of course, if you were to draw another ray, it will be, another ray will kind of hit there, and the focal length is up to 25 centimeters over here. So this will come and go to focal length, and this will also hit that point. Of course, I'm not drawing to scale, so I have to kind of curve it around. So we have a, that's, so if this point was A, this would be A prime, and this point is B, this point will be B prime. Okay, so this is a nice simple example. In this example, we are going to try to find image, location, height and orientation. Again, but this time we bring the object a little bit closer. Okay, so the object is 20 centimeter, focal length is 25 centimeters. So this object is nearer than the focal length. So when I work this out, we find that 25 centimeter minus 1 over 20 centimeter, this is larger than this, so Q is going to be negative. And you can see if I do 100 here, and just drop writing centimeters everywhere. Okay, so 4 minus 5 is minus 1 over 100. So Q is equals to minus 100 centimeters. So Q is going to be way out here. So this will be the Q, and this Q will be less than 0 because it's on the left side. Okay, on the same side as the real object. All right, so Q is minus 100 centimeters, and from this magnification formula, we can write down HI is gonna, which is just get magnification first, is going to be minus 100 over 20, which is 5 times magnified. So, and its orientation is positive, which means it's the same way as this guy. So HI is going to be 5 times 10 centimeter is 50 centimeters. So you can actually draw arrays, and let's draw this big. And to draw array from here, there will be chief ray which kind of goes straight through, and this ray would come to on the plane, and from the plane you can do, and these guys are actually parallel. They're not parallel, they're diverging away from each other, and so they'll never meet. They will keep going forward. So I think to do is to extend it and extend this, and it's going to meet somewhere there. So this is back extended. Of course there's a real ray, but this ray doesn't have information of this lens, but the back extension has the information of this ray. So this could be ray 1 and ray 1 prime. This is 2 and this is 2 prime, and extents of these guys meet over here. So if this is A, this will be prime image of that point, A prime, and this will be from this 50 centimeter. So this has the same orientation as that. So same vertical orientation as object. What we haven't done is, I'm not part of this question, and you may want to investigate, what if this object was like an L-shaped? Okay, this object looked like L. I want to ask you, will it be like this, or will it be like this? Which will it be? What do you think? You need to work this out, because you need to work out what will happen to this point. Now I have a point closer to the lens than this point. Will the image will be closer or on the other side or further? You can work that out. That's a good exercise for you. Okay, so I want both these examples were for converging lens. I wanted to work out an example for a diverging lens. Okay, let's work out the diverging lens case. So diverging lens defined as focal length is less than 0, or negative focal length. So for this negative focal length lens, we take an example with a minus 25 centimeter and place an object further than focal length, and we can have another object, it's this object 1, and this can be object 2, and this one can be p equals to 20 centimeter. Okay, so we can do case 1, this is case 1, and this is case 2. All right, so case 1 is 1 over q equals to 1 over f minus 1 over p, and 1 over f, it's going to be in a minus 25 minus 1 over 50. So this is now both of the same sign, so 50 minus 2 minus 1 is minus 3 over 50. So that just gives q equals to minus 50 over 3. So remember, we find 1 over q, so we have to invert it. So from there we can get magnification equals to minus 50 over 3 over 50. It's a plus 1/3, which means it's going to be smaller. The image will be smaller and 1/3 the size. So H image will be M H object, and so 1/3 of H object is 1/3 of 10 centimeter is 3.3 bar centimeter. Okay, how about the 2? is 1 over q is 1 over f minus 1 over p, so it's minus 25 minus 1 over 20, so common is 100, is minus 4 minus 5 minus 9 over 100, q equals to minus 100 over 9. So this m is going to be minus 1 over 9 over 50, because minus 2 over 9. So when it's got closer, I mean minus minus, so this is still same, it's going to be plus. This minus is, I should have a minus there. There's a minus and the minus. There's one minus here and another minus from the q. And if this was 3, then it's going to be 1/3. But this is 2, which means magnification is less. So even smaller, okay? So even smaller. And so hi will be 2/9 times 10 centimeter is 20/9 is even smaller. The object is same height, but the image got smaller and nearer. You can see q is this q is about 16.7 centimeters, and this is about minus 1 and about 11 centimeters. Okay. All right. So we have this elementary examples. Can do an example of a two lens system. Okay.